Welcome back to the Automation Podcast. My name is Shawn, and this week on the show, I meet up with Andy Watkins from Romi to learn all about modern-day CNC automation.
Andy, thank you for coming on the Automation Podcast to talk to us about what's new and exciting in CNC machining. I'm, as an automation guy, I'm aware that every big company has CNCing, but because my background's mostly in the PLCs, VFDs, HMIs, and whatnot, I really never got into the CNC side, but I know there's a lot going on with CNCs and automation, and I really appreciate you agreeing to come on the show and talk about yourself, your company, and talk about the new innovations. I know you was telling me in the pre-show that there's been a lot of new things happening over the last 5 years, so I really look forward to bringing our audience up to speed on what's new with CNCs. But before we do that, can you introduce yourself? Maybe take a minute to tell the audience about yourself, where you work, tell them about your company before we jump into the actual products.
Sure, Shawn. Thanks for having me on. Real privileged to be here. Andy Watkins is who I am, and I have a background in machining. And my approach to this world of automation and manufacturing that we live in and work in is kind of real practical. I come from a background of about 30 years doing this. I started out as a vocational student and worked through a number of different roles and responsibilities over the last 30 years, and it's kind of led me to where I'm at today. I learned machining, and I learned it the hard way and the good way. So I've got a real practical background, I think, anyway, and that's what folks tell me, so I guess they're right. Anyway, but what I do is I have been doing machining, and I thought it'd be a great opportunity for me when I got the opportunity to move to Romi Machine Tools to be their direct sales manager. And my territory covers Ohio, Indiana, Kentucky, but we sell globally throughout the world, and Romi is a kind of the best kept secret in town, and it's kind of my job to fix that. But they really have produced a product now for over 92 years in the CNC world, or in the machining world, and of course got into CNC as that advent happened. They brought in a lot of technology, a lot of partnership over the years, and have brought us to where we're at today. A lot of folks will know the Romi brand, and they'll know it through Romi Bridgeport. That was a partnership we had for a number of years up through into the 90s. And kind of the cool thing about that as a sales guy is I travel around all over my territory. I was up in Fort Wayne just last week and ran across two different locations that still had Romi Bridgeport machines in operation on a daily basis, a daily part of their operations. So it's a cool thing to do, get out there and see those older machines and then bring in the new technology and help customers, support them with their projects and what they want to do. It's a nice privilege for me because I can show them from a practical and machinist background what it takes to get done what they're wanting to get done. And so that's kind of my approach to everything, is just that, that background of machining and what we do and how we do it. It seems to be a real advantage in the field.
Just for the audio audience, we're sitting here looking at the Romi, ROMI.com website. It is absolutely gorgeous. And some of these CNC machines we're seeing just look so high tech. So let's just let you keep on going and jump right in.
Okay, great. Sounds good. The Romi product had, as we said earlier, we did have some key partnerships over the years. A couple of those I like to mention is we partnered with Bridgeport, and then over the years we also partnered with Mazak. And so we're located in Erlanger, Kentucky, right down the road from Mazak, because at that time we were partners, and with that partnership has moved on to other things at this point. But it kind of shows folks our seriousness in the market. Romi is a machine tool from a quality standpoint that competes with the best of the best. We build our own machine. We build our machine in our factory in Brazil. We own our own supply chain. We make our own castings. We do our own grinding, hardening, aging of the castings, sheet metal. about 90% of what goes into a Romi machine happens at the Romi factory in Sao Paulo, Brazil. So that's a real advantage. And we kind of are, not kind of, we are data heads here in the Erlanger office, and that's where I'm at today. We really monitor the market. We monitor what's going on, who's buying what, and what that gives us an advantage is we keep our machinery in stock because we know what's going to sell. And it's really given us a huge advantage in the market to be able to sell machines, have relevant machines for a customer. That's a big deal for us to be able to hit the ground running. If I got a customer that has a need, I can usually resolve that in just a couple of weeks, have a machine and have them up and running right back at it. And so that's a big help. I think the great thing about that, it shows how serious Romi is and how serious we take our customer and our customer care. We really focus on trying to help folks get solutions. And the great thing about that for me, I've been in their shoes. I've helped in operations. I've been partners in businesses. I've worked from everything at your top tier 1 aerospace manufacturers all the way down to a mom and pop shop. So I get it when they call and they say, hey, I need a part. Hey, I need this. Hey, I need that. We're there to help them, and we're going to be here. We're going to stay here, stay in this market, and really figure it all out. It's not like we don't have our challenges. We do, but we're working through them, and really focusing on how we get there and resolve these kind of matters for our customers.
Yeah, I think it's been a challenging time for many companies. And, there's only one choice going forward. Now, our audience is made up of engineers, people programming automation systems, people supporting them, electricians, technicians. And so I was hoping we could jump into some of it because you were telling me about all the cool things that these machines do now. So I was hoping you could jump in and start talking tech with us about some of the innovations in these machines that maybe we didn't see 5-10 years ago.
Yeah, we can certainly do that.
Before we get to that, I have a special announcement. I've just released my very first book. It's an ebook and it's entitled Logic's Book of Knowledge. What I did is I combined all my Control Logix articles from the last 10 years into an ebook. I updated them, I added new pictures, and I made it all available for just $9.99. So if you appreciate what I'm doing, if you want to support the show and the channel and the blog, then please check out my brand new ebook, Logic's Book of Knowledge, which you can get over at theautomationblog.com/BOK1.
One of the greatest advancements in CNC machining in general has been the introduction into, maybe some people in your audience know, maybe some people do not. Basically, we talk in the G-code language inside of our CNC controls, right? That's the big thing. And if you're a G-code whiz, that's great. But not everybody is. So how does a company that works in that kind of information, how do we get from that to being able to teach the younger generation, the newer generation, get them on the uptake, get them interested in the field, and see what they can do with these amazing machines. And so what we have partnered with, one of the control people that we have partnered with is Fanuc. And I'll show you some of these things. The Fanuc controls recently have just went to a whole new level, and I really enjoy them. One of the ways that there's about 3 major ways you can program any particular machine, right? So you got G-code, that's the old school long, that's like doing long form division by hand with a pencil. You can do that. That's great, I know guys that are just geniuses at it. Is everybody? No. And so how do you get to the next level? Well, one of the things is CAD systems, CAD/CAM systems. Those are very useful, but they're also very expensive. And you need verification if you use one of those, and simulation if you use one of those. Well, then along comes conversational programming. And that's been used historically in our business to be a way to have a conversation with a machine. And that's why we call it conversational programming. You're literally having a conversation with a machine to produce the end result, right? And basically the way that works is the machine asks the questions, you answer them, and those answers produce the end product. So it'll ask you, what type of material are you using? You'll tell it. And that matters because it matters how the speeds and feeds operate. Aluminum cuts differently than hardened steel, obviously. So that's an important part of that conversation. So conversationally, you go through and you lay out the sizes and you lay out the hole positions or the different features you're wanting to create. And so that's a really great thing. But what Fanuc has done is they have blended the all three ways into one really slick, really user-friendly format, so that you're able to reach a broader audience of operators, and that broader audience of operators is able to drive results inside of your business. The Fanuc Control, for example, is a touch screen. They call it the IHMI. So it's still an HMI, right? That's kind of how you and I get connected, because we're working with HMIs, right? But it's just a different field, right? So the IHMI, the Intelligent Human Machine Interface, is a touch screen. It's laid out kind of like an iPhone or a smartphone, if you will, with icons and applications or apps that are on there. Everything's a couple of clicks away, and it's kind of a new format. That's a great thing. The cool thing about it is, as you're programming this control, if you have that old school guy, he wants to stick with the old way, that's on there too. It's all on there, just like it always has been for Fanuc. And there's old Fanuc guys out there that, I don't mean old guys. I'm saying there's Fanuc fans from the back in the day. They want it to stay the same, and they want to be able to do that. So they've been able to achieve that with this Fanuc control. But the new stuff is just amazing. It's just really, really off the charts. We get a touchscreen control. We got the ability to conversationally program, so we're having this interactive conversation with the machine. We produce the program. That everything has to have a program. We produce the program, and this is where it starts getting beautiful. The conversational is great. It's easy to use. It's very intuitive. But then it goes on to the next great levels, and that's as you're producing the program, it's producing the CAD or the CAM models for you on the screen. Once that's produced, now I have the ability inside the control to do a simulation and a verification of that part program. And that's a really techie thing to have happen. There is a ton of background information that has to be present for a real simulation to take place. And I don't know if that's something everybody's exactly familiar with.
Yeah, simulation has become more and more popular. I just want to paint a picture for the audio audience. I mean, what we're looking at looks kind of like the standard CNC screen and keyboard that you would have, except of course this is a beautiful, gorgeous color touchscreen, and but you have that full alphanumeric keypad, and then you have all these additional buttons. You have an e-stop, so you're kind of looking at something. But on the screen itself, you see this menu that looks like it belongs on a tablet, right? And it doesn't look like an old school text-based or a legacy type system. It looks like a beautiful designed tablet menu system on this gorgeous flat screen. So I just wanted to paint that picture for our audience, as those listening who can't see, as before you go any further. So go ahead. I'm sorry.
No problem. That's really great. I'm glad you took the time to do that, because it's very different to look at. Some of my customers have looked at that, and at first their initial reaction is kind of like you described, like, wait a minute, that's really different. Well, in some people's mind, different is bad, right? Once they see what it works like, they're like, wow, that is really awesome. They go from different to awesome in a few minutes, just by looking and touching and feeling, seeing what works out. They get a real good idea very quickly of what they're dealing with. So, back to kind of that simulation context, I've been a programmer, CNC programmer, and designer with some of the most elite CAD systems made in the world. You know, very high dollar, high value CAD systems that are used by the aerospace engines and all these different places. When you get done programming in a CAD system, you always have the option to do like what's basically an animation. So it'll show you the cutter, the end mill, for example, going through the block of aluminum, and like, you know, according to the toolpath that you put on. But that is only so good, because if it doesn't have machine parameters and information built into that, it's only an animation. In other words, if there's something in the way in the physical machine, the animation won't know that, and it would take an end mill right through there and you'd have a crash. So people have developed simulation software. There's some major simulation software companies. That's all they do. And basically what they do is they take your CAD system, they take your machine environment, they put all that together in this big expensive package, and it does all this great simulation that you want it to do, right? Again, a lot of time, a lot of expense, a lot of effort has to go into that. When you can bring simulation to the machine control like we have on our Romi machines, you get the advantage. You're basically getting depending on the situation, you're getting between $50,000 to $100,000 worth of software for free, essentially, built into the machine. And what I mean by that is, as I've conversationally created my program, or G-code, created my program, I'm ready to machine features on a piece of material. I've got my program written. Now I can go and simulate that on the machine, and the machining environment is live. It's right there in that control. All the parameters are there. All your specs are there. You know, it knows the correct speeds and feeds, the size of the spindle nose. It knows the size of the table. It knows all these facts and features. You're able to import like the vise and work holding fixtures and things like that. So when you run it through the simulation, and this is where it gets beautiful and a major time saver, when you run it through the simulation, it says, hey, that doesn't work, or that does work. About 95% of the time, if you've got it right, when you go to cut actual piece of metal with an end mill, with a cutter, you're going to have a good part without any crashes first time through.
So you as a manufacturer, Romi, right? You
Yes.
guys you take these IHMIs and you tell them everything there is about your machine.
Correct.
And you tell how fast it can go, how the travel and just everything. And so that when you as a user go in here and say, okay, I'm going to go through the wizard, the conversation, and tell it what I want to make, it really knows. I mean, it really knows what the capabilities of the machine are already. So it can give you a cycle time estimation and other things based on, because this is not just some blank HMI that has no data in it. This thing's been programmed with the exact specs of your machine. Am I understanding that correctly?
Yeah, you nailed it. I mean, that's exactly right. That's a beautiful encapsulation of what we said. That machine knows itself.
Mm-hmm.
And that is so important. And I think that's kind of part of the topic of today. Like, we talked about automation, we talked about all of these different things. Why that matters in the world of the manufacturer today, and this is just my perspective, right? I don't claim to be an automation expert or whatever, but this is my perspective personally. I think when you hear the term automation, everybody goes to robots, tracked rail systems, an AGV, or whatever. There's all this like excitement and information and kind of a picture of like, wow, this huge mega system that's big robotic arms and gantry loaders and flippers and all kinds of stuff going on, right? Well, from my perspective, I sometimes wish that the term automation was just called simplification. Because if you you can drive a nail with a hammer, right? Your arm's going to get tired. But they came up with something to automate that, and it's basically a pneumatic or now battery operated nail gun, right? All you got to do is pull a trigger. It's a lot simpler. It automated nailing, right? But it just basically it's a complicated piece of equipment, but it made it simpler for the end user. So that's a big success. And that's what we're looking at. How do you simplify the day-to-day heavy lifting that the machine operator, that the engineer, that the programmer have to do, as they all have to work together as a system to make their company's product, if they're doing job shop work or they're doing 20,000 of something or 100,000 or 200,000 of something, how do they do that heavy lifting? It's really gets, as you start to drill down into the job shop environment, for example, it gets more and more important all the time. And I think this is how you get to that simplification, right? If the control can do the CAD work, if the control can do the simulation work, if the control understands the machine, if the control understands and can interact with the operator, right? Yeah, that's a lot of complicated stuff back in behind the scenes. And that's the nail gun kind of thing, right? But the operator doesn't feel all of that. He just knows he's more successful on a daily basis and he enjoys his work better.
Yeah, yeah. I think, back in the day when I got started in the early 90s, it was hard to explain automation to people. But today it's so easy because everybody has a touchscreen in their hand, right? So it's kind of like, if you remember, if you think back before we had, phones and, internet access, I mean, you want to create a pie, right? First, you would have to get a recipe on a physical piece of paper, right? Or memorize it. But if you, right. And then you probably, some of the things on that recipe, you probably wouldn't understand. So you'd have to have a dictionary or a cookbook to kind of explain, well, what does this mean? What does this mean? Whip, or, what are all the, what does it mean to grease the pan? And then, you if you want to set a timer, and then if you want to take a picture of what you created, you had to go get a camera, make sure you had film in it. And then to develop the film, you have to go down to the photo mat. And it's like, today you can do all this with the phone that you carry with you everywhere. Right. Look up the recipes. You can look at how-to videos. You can set a timer. You can take the picture and share. And that's the simplification. It's not about trying to replace everybody with iRobot, right? It's about using our time more efficiently, right? And that I agree with you. And I just want to go over some of the things on the screen right now for the audio audience that they won't be able to see, of course. Some of these menu things like data logger, right? Like manual viewer, like we talked about the cycle time estimation, machine collision avoidance, servo viewer, maintenance manager, right? So this is a full function HMI, a very smart HMI tailored for this type of machining industry. But there's a lot of features in here that I think the guys using standard HMIs, right, will feel very comfortable with. So this is a very powerful unit. But I think you did a good job explaining of, the why. Why do we want this? And the fact that your company's preloading this with the characteristics of your machine, so that when they're using it, they're getting an estimation. They know there's not going to be a collision. They can simulate creating this product. I just think that's amazing. And I never knew that was possible in CNC and machining before.
Yeah, it's made leaps and bounds in the last 5 years. This machine for us, the Romy D series milling centers and the GL series turning centers, they are our 5th generation machine for us. So we've been making this for a long time. But 5 years ago, we kind of stopped what we were doing and took a hard look at, not even though we've been in business for over 90 years and we know a lot about machine tools and we know how to make a piece of metal, into something. We took a hard look at our customers and we talked to our customers and we said, listen, folks, how can we help you? How can we listen to what you're needing? What do you need every day? And a lot of things came up like, we need a rugged machine. We need a reliable machine. We need an accurate machine. You need those things. But with the control in the last 5 years, when we came out and introduced our new series of the D and the GL series machines, both of those have this control, and that was a game changer. That's when it became so much more real, so much more competitive, so much more helpful to you as an operator every day. And I've been a machinist, so I've lived this life. I've went home with metal chip burns on my skin, and and I've had them lining all my pockets and my socks, and and my wife saying, take your shoes off at the door, don't you dare bring them old boots in here. And I've lived that life. And so when I look at that and I think, man, if I was coming up and I had this control, it would have been so much better, so much more intelligence involved. And I think, again, like you said, which you made a really good point there, this simplification of, just like the recipe idea, how much easier it is to just use your smartphone to make a loaf of bread or a cake or whatever. This is that same kind of technology, that same kind of simplification. How do you make this easier, and why is that so important? Well, everybody knows I get into about 100 machine shops or manufacturing plants a month. That's kind of my target. I hit that pretty much every month. And I have this conversation 100 times a month at a minimum. I can't find enough good people. Yeah. And it's just like every place I go in, if I had an old-fashioned tape recorder, I could hit rewind and play every time, because it's the exact same conversation. And it doesn't matter where I go. I've had this conversation in Tennessee. I've had this conversation in Indiana, in Chicago. I've had this in, Ohio, and it doesn't matter. Everywhere I go, I've talked to folks in Texas. I've talked to people in Florida. I've talked to just people all over the nation, and even around the globe in different places. But that I've talked to, they all have this issue where you just cannot find enough good folks. And that's the way it was back in the day when I was younger. You would, if a company needed 3 more machinists, 5 more machinists, it was no big deal. You put a sign out by the end of the road and they showed up by the droves, and you had a dozen to pick through. Well, that's not happening today. It's not happening anywhere. So how do you get more out of the guys that you have without overloading them? It's not about, okay, you guys have to work. You're working 12 hours a day. Now let's go to 16 hours a day. You're going to burn everybody out. So how do you be more effective? How do you produce more in the time that you have with the people that you have to get more effective? And this is a way you do that. This is how you get there. These machines absolutely will increase your output on a day-to-day basis when it really matters. It's like every day goes by, nothing really changed, but at the end of the year, you're like, whoa, what did we miss out on? What could we have done? And now we see that. And here's an opportunity for folks to really get into this type of technology and really get more with what they have today. I think that's the big takeaway with this.
Yeah, and I think we gotta think about who's coming into the workforce, right? I mean, these are people. They, like my grandkids, they grew up with touchscreens, right? And so if you show them an old CRT with a command line interface, they're not going to want to do that job. Now, when I look at this on your machine, I'm like, hey, I feel like I'm living George Jetson here. I'm going to make something from nothing. I'm going to take a hunk of metal and make something really cool out of it, but I'm not having to be like the 1950s with a CRT, And so, I think we the machines have to, also, they support the old G code, right? So the guy who's super efficient and just has spent a lifetime just becoming a G code expert, he is comfortable there. But, when you're getting new people off the street, people just getting out of the trade school, they have to be able to feel comfortable as well.
Yeah, and I think that is a really, really great point. And that is, I guess I was reading something the other day. They were talking about this generation, as you talk about the workforce. This generation is, like my kids are young, and this is the generation where they've always had a screen in front of their face. They grew up; they're natives, right, to this technology. They're the natives of technology, and they have these things presented to them on a daily basis, and they know and understand how to use it. And it's kind of like the old joke, I couldn't figure out my, blah, blah, blah technology, but I had my 5-year-old nephew fix it for me. And that's because they know what they're doing on it,
Yeah,
And
when I
yeah,
was a kid, is set the could you get the flashing light to stop the 12 to stop flashing on the VCR?
yeah, exactly. Yeah, yeah. 'Cause most kids wouldn't even know what a VCR was today.
Exactly. Yep.
They
Please be
barely even
kind
know
and
what it.
rewind.
Yeah, that's right. Every tape you ever had said that. So
Yep. Yep.
yeah, and it's so yeah, it is technology, and I'll tell you another perspective on that too, Shawn. When when I get into shops, like I said, I get into a lot of shops.
Mhm.
I go into these shops that are investing in this type of technology, and it's inevitable. I hear the same thing. Man, we are so busy. We have so
Mhm.
much work. I don't know how I'm going to keep up with everything. I can't get enough people. I've got so much work. I've got so much this, and it's good things. It's problems, but
Mhm.
it's good problems, right?
Mhm.
Um, and then I'll go right down the street in the same town, sometimes on the same road, and I'll go into the next shop, and it's all manual equipment. It's dimly lit. It's just so I don't hate to be stereotypical, right? But
Mhm.
it is so stereotypical of this group. And I'll talk to the owner, and I hear the exact same story. His story is it's a dying business. It's a dying trade. I can't get any work. I can't do any.
Yeah.
And it's the folks that take the time and the initiative and really it's probably scares them to death at times when they invest in that kind of
Oh
initially,
yeah.
like,
It's
oh man, I got to
expensive.
invest in this technology, there's this new control, it's this Romi machine, what do I do? And then all of a sudden they start hitting it, and they start getting real competitive on their price. People start seeking them out because there's still a ton of machining being done all over this nation.
Mhm. Mhm.
But investing in the technology, investing in your own business, you can't beat it, and it's how you win, it's how you succeed today, in my opinion.
Yeah, I hear you. Absolutely. I mean, you got to constantly be looking and being competitive, and I mean, in every area, every business, if you're uncompetitive, you eventually go out of business, typically. So it doesn't matter if you're farming, or if you're, if you have a store, or if you're doing automation. You gotta keep up with the Joneses. That's just part of competition, part of the free marketplace.
Yeah, and people use that phrase, keep up with the Joneses, and you're right about that. Sometimes that's given this negative connotation, and I guess if you've got to be the guy that has to have the best RV on the neighborhood block, I can kind of understand that. But in this world, in this manufacturing world, without investment in the technology, one thing you can count on for sure is that your competitor is investing in this technology. Real good example of this. I have a customer who was drilling a 2.5 inch diameter hole, 15 inches deep, in a piece of 4140 material. And that's fairly hard steel.
Mhm.
It's a tool steel quality. 2.5 inch diameter hole is a pretty, now somebody says
Yeah.
it's small, but, you know, the watchmaker's apprentice would think it's huge, but it's still a pretty good hole, and 15 inches deep. To drill that hole manually on a manual lathe was taking him 3 hours, and he made about 10 of these a month. Okay.
Wow.
So let's say he's only charging, I don't know, I'm just making something up just for easy numbers, right? $50 an hour. That's
Mhm.
a $150 feature in that particular part. I don't know what he's charging for the part, but let's just assume it's a $50 shop rate. 3 hours to make that. That's $150. Okay. So you think, wow, that's the way he bid it. That's the way he got the job. I'm making my rate. I'm good, right? So he ended up actually buying one of my machines and drills that same exact hole, still has the job, drills that same exact hole, 2.5 inches diameter, 15-inch deep in tool steel in 5 minutes flat.
Wow.
And that's no joke. I've watched him do it. I've seen him. That's the reality. Now, what happens? The guy, let's say those are two competitors instead of the same company.
Yeah.
You got a guy doing it for 3 hours at $150. $50 an hour, 3 hours,
Mhm.
$150. And then you've got the guy down the street that has the technology like we're discussing. He's making that part in 5 minutes. Let's say he's charging $150 an hour, but he's getting done in 5 minutes. who's making the most money.
And who can take the next order? I mean, if you're doing it in 5 minutes, yeah, you now can take so much more business than you could.
That's right.
Yeah, so you're not only, all around it's a win-win-win. You're producing the feature in the steel much quicker at a much lower cost, and now you can take more orders for other products. So it's just amazing.
And that's right. And that brings up a really good point too with the simulation, the IHMI control. So, and it's again this whole automation feature, this whole concept that you talked about, getting out grandma's recipe to make a cake, right? Mm-hmm. It's the same kind of thing with that IHMI control, because when you can make a part, one of the worst things in every machine shop will tell you this, they know this, setup is king. If you get good setups, you make good parts. If you make fast setups that work well, you make quick parts. Okay, so that's a big deal. Setup can be everything from programming to finding the right tools and setting the links to getting work holding and fixturing and tooling and all that stuff. And so setup is a big part. Sometimes it takes longer to set up a part than it does to make the part. And that just happens in our manufacturing world. So your time becomes very valuable. People will say, if you scrap a part, man, that costs 2 times the amount to make than it does to make it right. And I really disagree with that, because I say it's a 4x cost factor, and that begins to cost you a lot of money real fast. If you make the part the first time and you make it wrong, now you have to, all that time was wasted, right? So that's a loss.
Yep.
Now you have to go back and redo it all again. So there's time lost again. And then the actual machining time, again, there's 3. And then the 4th factor, depending on how you look at it, 3rd or 4th factor, is the opportunity loss for the next job you should have been doing. And the way simulation helps you with that, let's say you're programming something, the blueprint or the model says it's supposed to be positive 2 inches, and you accidentally put in negative 2 inches as you're fat fingering through the control. When you run the simulation, it shows up, oh, that's on the wrong side of that line. I didn't know that. So you get to go right there and correct it. So instead of that thing costing you 4x, you got it fixed in a minute or 2, and you move right on. So yes, that's where that extra time is. And the problem is these are kind of hidden factories, right? These are hidden checks and hidden cost centers that you don't know about. You don't feel it. You don't see it every day, but it's there anyway. And you've got to know how to get around that and really pull ahead by being, more correct more often the first time through. That's the cheapest way to make anything, is make it right the first time.
Yeah, I imagine, there's excess wear and tear if you have to make parts twice to make one good part. But also, I'm assuming some of the stock is fairly expensive too. Not all of it, but I'm assuming some of the stock would be very expensive. So if you're scrapping that stock, the piece you were drilling into and messed up, I imagine that's a pretty big expense as well.
Well, when I worked at one of the tier 1 aerospace companies, we worked on proprietary materials. And you know how many parts we had to make to get it one right?
Oh no.
We had 1, and it was $500,000.
Wow.
Piece of material that was irreplaceable. There was no backup. They were inventing this as they go, but we still had to machine that part. No pressure, right?
Yeah.
But you
measure twice, cut once.
Yeah, right. Well, one of my mentors when I was growing up in the business, he said, I cut it off twice and it's still too short, that was his favorite joke. But yeah, that's kind of where you're at. So yeah, that's a really good point. You get a piece of material, and right now material is very difficult to get a hold of. A lot of folks are, there's stuff out there and people are getting things, but it's delayed or it's taking more time. So today, when used to be, if you made a mistake, no big deal, just call up your steel supplier. He'll drop you something off tomorrow. You get it, by noon. You'll have it done by Friday. You'll be good to go. But see, that expense, that cost is hidden oftentimes under that you just don't notice it. But today, if you call that steel supplier up, he might say, yeah, I'll get it to you next month. Now you're in a pickle real quick. Now what do you do? And how do you get around that? So it's so much more important today. And it's again, simplification. How do we simplify? How do we automate / simplify these types of daily operate? This is daily stuff. This goes on in thousands of machine shops throughout the United States and the world every day. Every day this stuff happens. If you could capture that tally of the loss based on these kind of things we've been talking about, it'd be astronomical.
Yeah.
It'd be in
Cutting waste,
billions.
saving time, cutting waste is always huge, right? Especially in this industry, right? In many industries, people are the most expensive commodity, but I think in this industry, you'll find a lot of times materials and time can be the most expensive quantity, part of the of whatever you're doing, right? Whatever you're making.
Yeah.
So very important.
Super, super important.
Well, Andy, I really appreciate you taking the time to bring us all up to speed on what's new in the CNC technology and these IHMIs, and get a look at the Romi machines. And man, they're gorgeous. They're gorgeous. And I appreciate you coming on the show and just taking the time to have a talk with us.
Thank you so much, Shawn. It's a real privilege to be here and get to talk to your audience and share the little bit we know, and just kind of, being a little bit of an eye opener to this technology and what's out there today. Our whole goal is to help people succeed, and hopefully this drives to that. So we really appreciate you taking the time and inviting us on and making this a part of your show. Thank you so much.
Well, I hope you enjoyed that episode, and I want to thank Andy for coming on the show and bringing us all up to speed on what CNCs are doing today as far as automation is concerned. Now, if you did enjoy this episode, please consider giving us a like and a sub. And if you're listening to the audio-only edition, please consider giving us a 5-star review. It really helps us grow that audio audience. And I do want to thank everybody who has already done so. Really appreciate it, guys. Now, if you want to follow me or get in touch, you can do so at automation.locals.com. And if you want to check out my courses, you'll see them over at theautomationschool.com. That said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.